Morning students, Sairam, this is Megha Miss here, and today we will do with our lesson number 4 effects of electric current. This is our revision part 3 students. Okay, in the last presentation we saw about the same chapter revision, that was of part 2 you saw. We'll continue with this part. Okay students, so the next part which you studied was about the galvanometer. As you know, this part is not there in your portion for this year, but as it is connected with your experiment which we are going to study further, so I have just introduced you with the galvanometer. Okay, what is the galvanometer students? In galvanometer, the pointer deflects on both the sides of the zero mark depending on the direction of the current. So you will remember, see the picture of the galvanometer, it looks like this. Okay, it has got both positive and the negative terminals. Okay, you can see that red color and black color buttons on that. Okay, now what it is used for, it is just used to show the direction of the current. It will show you the direction of the current. Okay, in the middle it has got a zero mark and a needle is there which can pointer, or you can call it as a needle, which will deflect on both these sides. Okay, depending upon the direction of the current. Okay students, so we'll proceed further. Now we are doing one experiment, what to see how is the current flowing. Okay, now collect the material as shown in the figure 4.15. You can see it here. Now complete the circuit by connecting the galvanometer. We are using a galvanometer to see the direction of the current. Okay, keep the bar magnet erect in such a way that its north or south pole is just below the copper wire. Okay, any of the poles you can take, and I have kept it just below. You can see this is my copper wire. Okay, now if the wire is kept moving from A to B, if I am moving it from A to B, the pointer of the galvanometer gets deflected. Okay, now what if I am moving the wire? The pointer is also getting deflected in the galvanometer. Okay, this is called the Faraday's electromagnetic induction. Okay student, what you will call this as, because the current is also moving when you are moving the wire. Okay, now move the magnet with the fixed wire. Okay, the galvanometer pointer still get deflected. Now what we are doing, now we are moving the magnet also. First we didn't move the magnet, we moved only the wire, and what we moved is the, with the wire the galvanometer pointer deflected. Now what we are moving along with the, what we are doing now, the magnet with the wire fixed. You have now moved the magnet, wire is fixed position, now I am moving the magnet, then also you will see that the galvanometer pointer is deflecting. Okay students, now we will proceed further why this is happening. Okay, now see here, complete the circuit as shown in the figure 4.16a. You can see. Okay, discuss about and select the components as required. You know everything, you will read a battery or a cell, a key. Okay, to complete the circuit. Yes, in this experiment, if we open the plug key and make the current 0 in the coil, the pointer of the galvanometer deflects to the side and quickly comes back to 0. Means if there is no current flowing, galvanometer will be, the pointer will be on 0. Okay, if the current in the coil is started again, now if I start the current in the coil, okay, what will happen, the pointer again deflects to the other side and then returns quickly to the 0. Means it will show that current is flowing and it will come back to the 0. Okay, we'll proceed. Now when the electrical current is flowing through the solenoid coil and the solenoid coil is displaced with respect to the coil, the current is still produced in the coil. Okay, now instead of a single wire, copper wire, if I take a solenoid, yes, you know it is spring like, right? You can see it in the picture also. Then what you are seeing, then also you will see that the current is produced. Yes, what you can see, when the electrical current is flowing through a solenoid coil and the solenoid coil is displaced, means if I am moving the solenoid coil, okay, with respect to the if the solenoid coil is displaced with respect to the coil, means you have this solenoid coil also, and if you have this coil also, with respect to that, see, you can see with the arrowheads, if I am moving it sideways, the current is still produced in the coil. You will see that in this coil you will see the current is produced. Okay, we'll move to the next part. Next part is what can be inferred from these two experiments. Now from this, what you can infer. Okay, even if the solenoid coil is kept stationary, means I am not moving it, a change in the current in the solenoid coil produces a current in the coil. Means because of this solenoid coil, there is a current produced in this coil also. Okay, if the solenoid coil is moved towards or away from the coil, we see a deflection in the galvanometer. Also, the faster is the displacement of the solenoid, larger is the deflection of the galvanometer pointer. If I doing it slowly, you will see that yes, in galvanometer there is a deflection of the pointer, and if I do it very fast, then also there is the faster, larger deflection in the galvanometer pointer. Okay, students. If the current in the solenoid coil is changed, now if I am changing the current, a current is produced in the coil, or if the solenoid coil is moved towards the coil, then also current is produced in the coil. Means if I take solenoid coil towards this coil, then also the current is produced. A current is produced in the coil, okay, even if there is a change in the current. Okay, students, I hope you understood this part. Okay, we'll proceed to the next part. So, from that, now only we saw Faraday's electromagnetic induction. Now, what is this Faraday's laws of induction? We will see. If a current is switched on or off in the solenoid coil, a current is induced in the coil. Okay, some current is induced in the coil. Okay, such an as induction is also observed when the current in the solenoid coil is increased or decreased. Okay, if I can increase the amount of current, or I can decrease the amount of current. Okay, current is induced in the coil when it is moved aside from front of the solenoid. Okay, then also you saw the current is induced. From this experiment, it is understood that whenever the number of magnetic lines of force passing through the coil changes, current is induced in the coil. Okay, thus this is known as Faraday's law of induction. Means the current is produced in that coil because of whom? Because of solenoid coil. Okay, the current produced in the coil is called as induced current. What you will call, students, such current as induced current. Okay, students, I hope you understood Faraday's law of induction. Okay, we'll proceed. Fleming's right hand rule. Now, what is this Fleming's right hand rule? When will the induced current in the electrical conductor, that is coil, be maximum? It will be maximum when the direction of the motion of the electric current is perpendicular to the magnetic field. Okay. In order to show the direction of induced current, Fleming's right hand rule is very useful. And this is the Fleming's right hand rule. What it is telling us? Stretch the thumb, the index finger and the middle finger in such a way that they are perpendicular to each other. Important, they should be all perpendicular to each other. Okay. In this position, the thumb indicates the direction of the motion of the conductor. The index finger, the direction of the magnetic field, and the middle finger shows the direction of induced current. This is the rule known as Fleming's right hand rule. Important, if you remember this diagram also, students, you can write the rule on your own. Yes, thumb is showing you motion of the conductor. Yes, then what it is showing? Index finger is showing you the direction of the magnetic field, and the middle finger is showing you the direction of the induced current. Okay, students, I hope it is clear. Yes, we will proceed to the next part. Next, you studied about the electric generator. Yes, AC generator, if you remember. DC you don't have. Okay. We have seen the experiment based on electromagnetic induction. The current produced in this experiment was of very small magnitude. Okay. But the same principle can be harnessed, means used for the use of the mankind to produce large current. Here, mechanical energy is used to rotate the current carrying coil in a magnetic field around an axle, thereby producing electricity. Okay, students? Now see here. This is our electric generator. Figure 4.20 shows a copper wire coil ABCD. Yes, you can see in the diagram, kept between the two poles pieces of a magnet. The two ends of the coil are connected to the conducting rings R1 and R2 via carbon brushes. Okay, so these are your R1, R2 are shown here. See, this is your R1 and R2. Okay, both the rings are fixed to the axle. You know this part is your axle, but there is a resistive coating in between the ring and the axle. The axle is rotated with the help of a machine from outside. Because of this, the coil ABCD starts rotating. This coil will start rotating. Okay, students, I hope this part is clear to you. Basic construction part. Now, the stationary carbon brushes B1 and B2 are connected to a galvanometer. Now only we studied, which shows the direction of the current in the circuit. Now you have understood the use of a galvanometer. Okay. Upon rotating the axle, the branch AB goes up and branch CD goes down. Yes, this AB will go up and CD will come down. Okay, that is the coil ABCD rotates clockwise. Okay, students, we'll proceed. I hope till here it is clear. Now, according to the Fleming's right hand rule, the electric current is produced in the branches AB and CD in the direction A to B and C to D. Okay, you can see the arrowheads. Thus, the current flows in the direction how it will go? A to B to C to D. Okay, as shown by the arrows in the figure, you can see it. In the external circuit, the current flows, means the outside circuit. Okay, the current flows from B2 to B1 it will go. Okay, through the galvanometer. If instead one loop coil, a coil consisting of several turns is used, the current of magnitude several times flows. Means if you increase the number of loops of the coil, more amount of current will be flowing. Okay, now after half rotation, the branch AB takes the place of branch CD and the branch CD takes the position of branch AB. Therefore, the induced current goes as, now it will go anti-clockwise, D to C to B to A. But the branch BA is always in contact with the brush B1 and branch DC is in contact with the brush B2. This will be always there. Okay. Hence, in the external circuit, current flows from B1 to B2, that is opposite to the previous half rotation. This repeats after every half rotation. Like this, it is rotating, alternating current is produced because of this, and this is what we call the AC generator. Okay, students, so I hope this part is clear to you. I have also sent some video in the group. I hope you have seen that for this electric generator. Okay, just the diagram, working part and construction. Based on this diagram, questions can be asked in your exams. Okay, final exams. Okay, students, so we'll proceed. Now, we are going to do, this is the end of the chapter, was our AC generator. Now we are going to do is some revision questions based on the lesson number 1, 2 and 4. Okay, students. The first question is filling the blanks by choosing right option. I told you the paper pattern in the last your presentation. At the end, I told you the paper pattern, that your last 8th and 9th question, answer in brief and answer the following. Okay, in short, are going to be the questions where you have to type the answers. Okay, that is the 5-mark questions are there. 2 and 3 it is divided. Okay, so better remember that you have to type the answers. Now these are the some MCQ type of question which I am taking. Filling the blanks by choosing right option. First one, the orbit of the planet is an ellipse with the sun at one of the dash. So you have to just click on the right option. Now you guess what is the right. A option is foci, B is center, C is surface. Yes, one of the foci. So this is your right answer. Okay. Now dash halogen is in a liquid state. So which halogen, students? Is it chlorine, iodine or bromine? Yes, it's the bromine. So bromine you are going to tick as you did in your unit test papers. Okay. The unit of electrical power is dash. Yes, you know what is it? Yes, it is watt, newton or volts. It is watt. Okay. The live wire and the neutral wire have the potential difference of dash volts. How much volts it is? Yes, students, you will remember it is always 220 volts. That is the B option. Okay. I hope such type of questions you are going to get. So you are going to practice it. Okay. Read the textbook, please. Okay. Not from the back side of the textbook only you will get the questions. State true or false. The neutral wire is connected to the earth. Is it true? No, it's a false statement. Yes. I hope you know this. You have read it. Okay. Silicon is an example of a metalloid. Is a silicon metalloid? Yes, students. Is a silicon metalloid? Yes. So it's a true statement. You will write it true. You will get option true and false. Okay. 2 options both you will get. You will click on the correct one. The electron capacity of M shell is 2. Is it true? No. It's a false. Okay. The energy stored in an object because of its position or state is called the potential energy. Is it true statement? Yes, students. It's a true statement. So, true. Now complete the correlation. Valency of sodium 1. Valency of carbon, yes. Now you should know the atomic number. Now carbon atomic number is 6. So 2 and 4. Yes. So last shell you have 4 electrons. So how much it should need? How many electrons it will need more? 4 electrons to complete the octet, right? So the valency will be 4. That is the B option. Okay. Voltmeter device for measuring potential difference. Dash device for measuring the current. Can you see it here? Yes. So which is the device which we are using for measuring the current, not to see the direction of the current. Read the question properly. So our answer is going to be, students, galvanometer or ammeter or resistor. Yes, it is going to be the ammeter. Okay. I hope it is clear. Okay. Now the next part we will see. See here. Observe the figure and answer the following question. Okay. Now the force of the gravitational between the two bodies having irregular shape is taken to be distance between their dash. Okay. Center of mass, center of the body or edge of the body. What you will take, students? What will be the answer? If it is of irregular shape, the force of gravitation is taken as, yes, it is taken as A option, that is center of mass. Okay, students, I hope till here it is clear to you. Okay. Now, so we have practiced some of the questions also. I have included from first, second and fourth all lessons. I hope this much revision is clear to you. All such type of questions you are going to get in your exam, and I know you will solve it very nicely. Okay. So all the best for your exams. Do well in your semester, students. Okay. So I'll stop it today here. Thank you. Sai Ram.